Welcome. This is going to be our classwork help video for the compound interest worksheet. On the front side here, I've got a bunch of just basic compound interest formulas that you need or compound interest questions that you need our compound interest formula for. That formula is A equals P for initial amount times 1 plus the rate expressed as a decimal. Don't add the 1 in here. This 1 over here is doing that job for you. Divided by n, the number of compounding periods per year, to the power of n times t, where t is the number of years. All right, so let's try plugging in number 1 into that formula. So our initial amount is 26,900 times 1 plus our rate, 0.15, divided by compounding periods, which is 2 for semi-annually, twice annually per year. For 2 years. So here, nt is 2 times 2, but I'm just going to write a 4. That's one of the most common spots to make a mistake, is raising it only to the power of like the 2 and then multiplying the answer by 2 instead of raising the value to the power of 4. All right, let's plug this in, see what we get. You can plug it in exactly like it looks in one line in your calculator. 26,900 parentheses 1 plus 0.15 divided by 2, close parentheses, to the power of 4. And I get 35,924 and 12 cents. We'll just always round to the nearest penny in these problems. Now a way to kind of double check this is just say, well, 15% for 2 years, well, that's basically like getting 30% once. So I'm just going to do a simple interest calculation, 26,900 times 1.3. 26,900 times 1.3 gets me 34,970. This should be more, but not that much more. So it checks out. All right, so we did semi-annually. Let's do one that is monthly. We'll do number 6. 42,000 times 1 plus 16% as a decimal is 0.16. Monthly is 12 for 2 years. Well, there's 24 months in 2 years. Plugging that into my calculator exactly as I see it. Raising it to the power of 24 because I did that step in my head, and I get $57,717.19. And then we'll double check by doing 42,000, and we'll say 16% for 2 years. That's basically like getting 32% once. So multiply by 1.32. And we should get a number just a little bit less, but not that much less. We get 55,440. So that's our double check. And that is actually the formula for simple interest right there. Okay, annually, this one, it looks like it's a little bit harder. Sometimes students make more mistakes when it's annually, but annually, n just equals 1. It actually makes the problem easier. 53,400 times 1.08 to the power of 8. That's all you have to do here. Because we're not breaking up that 8% into compounding periods, it's just like multiplying by 1.08 8 times. So 53,400 times 1.08 to the power of 8, all in one line of my calculator. And we get $98,000, 839.67. So 8%. For 8 years, you're almost doubling your money. This is the effect of compound interest. And the rest on the front side are up to you here. But what I'm going to say is that this isn't how investing really works. Normally, our money is growing, but we're also adding amounts to it as it grows, as we earn more money. It's not like we just put away $50,000 and then just wait. You put away some money, then you keep adding to it. So that's what the backside's going to be about. Let's do our double check here. 8% for 8 years, that's like basically earning 64%. Let's see what this number is if we increase it by 64%, 53,400 times 1.64, we get 87,000. That's close enough to this number that I don't think I made a mistake. Yeah, the gap there will get bigger for the more number of years. Okay, so here's a little bit more realistic scenario. We are depositing $250 each month into an account that's paying 6% compounded monthly. So really important for these problems is we've got to figure out what the actual monthly percentage is. 6% over the course of a year is what percent each month. So do your 0.06 divided by 12 to get 0.005. That's the percentage I'm getting each month. Add 1 to it, so I get my full amount back plus this percentage. I get 1.005. All right, now it's best to think about these problems backwards. Think about the very last $250 you deposited. It only gets to compound one time. You add it in that very last month, and then it compounds at the end of that month, and it gets to add to your final balance. So it gets multiplied by 1.005 only one time. All right, then go back in time. The $250 you plugged in November got to compound twice. It got multiplied by 1.005 two times. All right, now we can skip all the way to the very beginning. The very first $250 you plugged in got to compound 5 years times 12 months equals 60 times. And here we've got a geometric sequence. So we're going to find the geometric series, aka add them all together. The formula for this, the series of a geometric, the sum of a geometric sequence or a geometric series is equal to the first term times 1 minus the rate to the power of n. Make that look more like an n, all over 1 minus the rate. In this problem, our first term is that 250 times 1.005. Our rate is the 1.005 because that's what we're multiplying by each time. The n is 60 because that's how many terms we have. And this goes on the bottom as well. So 0. And this can be plugged into your calculator. Now when I plug this into my calculator, I kind of add a separate parentheses around the top and the bottom here, even though that's implied by the fraction. That's an easy spot to make a mistake. So I've got my 250 times 1.005, that gets me 251.25, so that's how much the very last deposit is now worth. Multiplying that by parentheses 1 minus 1.005 to the power of 60, close parentheses, divided by 1 minus 1.005. And I get $17,529.72. Now our double check on this one is we just ignore the interest entirely and we just say, if I deposited $250 for 60 months but didn't earn any interest, I would have 15 grand. All right, it's close but a little bit less, so that completes our double check. Okay, and now for the question we've all been waiting for. How much should you save each month in an account that pays 9% compounded monthly if you want $1 million to retire with in 45 years, aka 540 months? So take that yearly interest and split it into months. This is important. And we get 0.0075. That's the percentage we're earning every single month. We know our final amount. We know that we want $1 million over on this side. All right, what we don't know is that initial amount, and that initial amount is going to tell us how much to deposit. So this is a sub 1. All right, now in the formula we do 1 minus our rate, 1.0075. I added a 1 to this so I get my full amount back, to the power of 540 divided by 1 minus 1.0075. I can turn this into a single number. by just plugging into my calculator, 1 minus 1.0075 to the power of 540. Get this really long decimal divided by, in parentheses, 1 minus 1.0075. Then I get $1 million equals the value of our very last deposit times 74,000 or 7,400.87. I'll keep this number in my calculator and divide 1,000,000 by it. And I get 135.046 equals a sub 1. Now remember, this a sub 1 already has our, amount. We'll call it the principal times a 1.0075 built in. So divide this by another 1.0075. It's not going to change very much. It's just going to become $134 and it looks like 4 cents, but we actually want to go to 5 cents in this one. It makes sense to round up, even if it's just a fraction of a penny above 4 cents, because if we don't round up, all those pennies will add up and we'll end up a few dollars short of our $1 million at the end of 540 months. So definitely still round up. That's how much we have to invest each month. Remember this number. This is a really good goal once you get your first job, to save $134 every month towards your retirement. Can you do it? It's gonna, this might seem like a big number early on, but it really does pay off if you can save $134 every month. That is your goal. Try to remember it. If you take one thing away, it would be that is a good number to start saving, because 9% is doable in some very risky investments, but you're able to take some risk when you're young and get that 9%. When you're closer to retiring, you want to move all that money into safer investments. But that's enough out of me. Have a good rest of your day.